Our next speaker, again from Charter, is Rosaiah Jujjuru, and he's going to be talking to us about a case study on Blackout implementation using SCTE-224.
Hi all, good afternoon. This is Rosaiah Jujjuru. I am from Charter Communications, going to present about the Blackout implementation at Charter. So we have started with SCTE-224 and how we extended our solution to support 224. The objective or agenda of this particular presentation is how we are going to support the blackouts and what are different use cases we have for SCTE-224 and 224, and what are the challenges we faced while implementing this blackout, and also how we have to convert the SCTE-224 data into the ESAM understandable signals to the DCM encoders and packagers, and also about what are the future directions from SCTE working group and how we are going to forward with those directions. So basically, with the current providers, with the current content providers and programmers, we have analyzed like there are around 3 types of blackouts. So one is basically the geo-based restrictions for the QAM flow. Basically, the QAM is with the DCM, and the DCMs are particular to the market or a particular area. So we call it as a zone-based blackout for the QAM flow. And for IP, generally we are doing different kinds of blackout with IP. Either you can do at encoder level, or you can do with the manifest manipulator level with the JIP based from the devices. And so we have a special requirement for some of the content where we have to do a blackout when you are out of home. So basically the out of home means like you are not connected to the Charter modem and you are outside of Charter modem, then based on some of the content we have to provide a slate. And also based on the signal delivery and based on the type of blackout, some programmers will send their blackout instructions through in-band, which is SCTE-35. So we are parsing the SCTE-35 and identifying the program start and different identifier, and also the web restrictions flag. There are a lot of things we can analyze the SCTE-35, and then we are doing the conditioning based on the SCTE-35. And the other type of blackout is out of band blackout. This means we don't have any signals from the content, like no SCTE-35 markers. Then we can use this out of band, and it is completely time based, and the triggering will be from the alternate content system, and no signals will be available in the content, and ACS will send an ESAM signals to the DCM or encoders or packagers. And the third use case is like basically it is a combination of in-band and out-of-band. So it's basically a SCTE-224 format. It doesn't have any specific type, it's in-band or out-of-band. It will does both. It checks the matching signal and then it checks the data, and based on the matching signal it will apply the blackout. If there is no matching signal, then it will be out of band. So the SCTE-224 supports both in-band and out-of-band. And not only these requirements, and we consider our operational requirements as well to make our friends operation team to make their life easier. So how we are monitoring the platform? Basically we want to see the communication flow is good and it is not broken. If it is broken, and we have to alert our team to get immediate attention to those particular scenarios. And also like it's very difficult in the big scaling platforms to understand whether the event is successful and the flow is very good. So we have to give a proper troubleshooting mechanism to the operations, whether the event is successfully happened or not, it is the slate is switched properly or not. Those kind of information has to be logged, and it has to be provided during the troubleshooting scenarios. And also we have to provide some kind of dashboards to see the status of the event, whether it is successful or it's a fail. So based on that they can go for the troubleshooting. So we are considering all these requirements, and based on that, and also With the SCTE-224, the level of complexity increased, and it's not easy to troubleshoot any events, whether it is successful or failed. So we had to use the audit mechanism to find whether this particular event is successful, because there are a lot of reusable elements in SCTE-224. You can use the same particular elements for multiple events which are in progress, so it will be very difficult to understand whether the event is failed for what reason. So we have to do audit for each and every element level. And the last one is like, how do we support, like if more content providers are coming and they have the large data and we want to scale our platform to support, and it has to be easily failover, and we can recover quickly when any problem comes or any distraction happens. So this is our architecture which we are supporting for both QAM, IP, and so we are having at the top layer, we can see different types of interfaces which are RESTful interfaces. We will get the data from different content providers. So some content providers will send that data in SNIO2, and some guys will send that, unfortunately we are receiving the data in CSV files, spreadsheets, emails. Still we are finding the way how to avoid that, and we built our own component to convert that data into SNIO2. And if any content provider who are providing that data in IO2 today and they want to change it into 224, so instead of them converting the data, so we are converting this particular data into 224 format, even though they are providing in IO2. So that in the next time when they migrate completely to 224, they can see all the data in the system in 224 format. And the other interface, directly we are supporting 224 format. So once we get the data is too large, and we want to simplify the data and to make the decision quickly during the event. So converting the data into an understandable format where we can give quick responses back. So we have divided our rules into two different scenarios, like QAM is different and IP is different, so that we'll scale our platform to support for both QAM and IP. So in the QAM scenario, it is a DCM. So the DCM is used to send the signals to the ACS, and ACS will take the decision and do the conditioning, and then the switch will, the slate switching will happen at the encoder at the DCM level. In the IP scenario, it is totally different, and we will get the signals from the encoder, and then we'll do the conditioning through the ACS, and it goes to the packager, and packager also sends signals to the ACS, and again ACS will do the manifest conditioning, and it inserts appropriate alternate content tags. And finally, the manifest manipulator, during the event time, when the device sends a request, it will take the IP of, the zip code of the device, and it looks into the database, and based on the comparison, it stitches either alternate content or slate based on what the content provider is providing in the event. So we have a different mechanism, and lastly, we have the out-of-home scenario, like some of the content, some of the programs, when you are not in charter network, you have to block it. So during those scenarios, we are using the out-of-home encoder, and again, the blackout is not happening at the manifest manipulator level, it is happening at the encoder level. So we are serving all the three use cases using this particular scenario. So okay, and now what are the challenges we faced while implementing these blackouts? So basically, everyone knows like 224 comprises audience, viewing policies, media, and media points. There are a lot of elements involved. And using this audience, like we can provide zip code, we can provide DMA, we can provide virtual IRDs, we can provide zone information, and we can provide device information. There are a lot of elements available in the audience. So it is very straightforward if you implement for IP blackouts, but for QAM, it is very difficult. The problem is QAM is like a zone based, so you have to do conversion from like a zip to zone or a VRD to zone. So there are a lot of overhead involved on the ACS system. So basically, we want to see that how we can get the information directly from the content provider in terms of audience, like how do you differentiate QAM and IP, so that we will reduce the overhead onto the ACS system so that the decision will be quicker. So, and the SCTE-224 is very wide, and it's a lot of optional elements are there, and we don't have a proper way of identifying what is a program start and program end or chapter start or chapter end. So it is completely event driven and event based. So a traditional SNI-IO2 is difficult to convert into the 224, so there are a lot of steps involved in doing that. And again, like this is 224, and we are dealing with a lot of old systems like DCMs and encoders. So we want to convert whatever the data we are getting in SCTE-224 into ESAM format. This is another challenge. How do we convert those messages and send it to the DCMs and encoders? And also, like as I mentioned, that it's a very wide, the SCTE-224, and a lot of optional elements are there. There are no restrictions. You can do whatever you want, and it's very difficult to control at the structural or schema level validations. And the third one is like we are not having much information about how to capture the audit information. Like as I mentioned, a lot of elements involved, and a lot of elements are reusable for different events which are in progress and which you can use it for future. Then it's very difficult to get the audit at a particular moment, and we are looking for some guidelines from SCTE working group how to use the audit properly. So these are the future directions or recommendations or the next steps. What we want from the SCTE working group is like how do we efficiently use SCTE-224, like as we already discussed that, how do I convert a SCTE-224 message into proper ESAM. So it's an implementation specific, otherwise each vendor will do their own way of converting it, and we want some kind of guidelines. So, and also we want to standardize the schema, like we have a lot of optional elements. Everything is open, like you create a program start without program end, which will accept. You create an event start without event end, it will accept. So we have a lot of things like that, and we want to restrict the schema or provide more guidelines how to use it. And we want to use this, the wider adoption of SCTE-224, like still a lot of content providers wants to send SNI-IO2 because it's very easy to send the events, and nobody is looking for the complexity, and they don't want to use the SCTE-224, so we want to encourage a lot of content providers to use SCTE-224. So, and the third one is like, it's a new standard which is upcoming, SCTE-250. So basically the 224 is not for ESAM. It's basically designed 224 to support with SCTE-250. And we want to see that how the integration between 224 and 250 and what are different formats the 250 is offering, and how the encoder is going to adapt those changes and the DCM is going to adapt those changes. It's a lot of challenges, and we want some future directions. So stay tuned, we'll get more updates on SCTE-224 from SCTE working group. That's all for now. Thank you all.
Thank you, Rosaiah. I'll take prerogative for one question. There's a lot of optionality in the standards. Does that mean we need an industry recommended practice?
Correct. So that's what we are looking for, like schema level restrictions. If that happens, we can control some of the things, like we can restrict how to implement based on the schema is one way, or you can provide some guidelines, like you have to use start and you have to use end. So without using end, you cannot do another start. So those kind of guidelines has to be provided by the working group.
Thanks. Sounds like we have some more work to do in SCTE, but please join me in thanking Rosaiah. Thank you very much.